Well, hello friends, and welcome back to OS Hacking. Today we are going to do some kernel work, and it's going to be about file descriptor passing. So file descriptor passing is a feature I've wanted for a long time in Serenity and just never worked on it. And the basic idea is that when you have a socket communication between two local processes, then one of them opens a file and then he sends the file descriptor for that file over the socket to the other peer, and now the peer can open that file descriptor in his own process. And this is something that would allow all kinds of interesting interactions and give us much more opportunities for privilege separation and process separation, right? An example of something that we might like to do is instead of something like text editor having a file dialog where it like browses the file system, it might delegate that work to a file dialog service that provides the file browsing, and then it opens a file, and then the text editor program simply receives an open file descriptor from the file dialog service. And then the text editor program doesn't need to have any kind of directory access. It just needs to talk to that one service. So it's a way to further whittle down what we already what we allow processes to do, basically. So this will open up interesting opportunities like that and solve other problems. Anyway, let's not talk about it forever. Let's instead just start working on it. So I don't know that there's a standard API for this kind of thing, so I'm imagining something pretty simple, like say that we put this in, I guess in socket.h maybe. So we would have an API, something like send file descriptor with the socket that you're sending it over and the file descriptor that you're sending. And likewise, like receive file descriptor, something like this. I think that on Linux, for example, you do this using send MSG or something like that, and there's all kinds of other business, but I don't know that it needs to be more complicated than this, although this API here is clearly silly. So this is the way it should be. And then the way that we would, the way that we know that a file descriptor is coming from the other side is that this will be like out of band, right? So it's not gonna, the file descriptor number is not gonna be part of the data stream, but it will rather be something that just like hangs on the socket, if that makes sense. So let's just start to implement this and see how it ends up. I have not done that much thinking about this, so we'll see. Oops, that's the wrong file. So let me just write out these syscall wrappers here for libc. So this will be something like rc syscall send file descriptor sockfd and fd. And likewise, so receive file descriptor, it's going to return an open file descriptor if we get one, and an error otherwise. So I think that will make sense. Okay, yeah, it doesn't need to be more complicated than that. Is this a thing on Linux, by the way? I actually don't know. No, okay. And then we'll go in the syscall table and we'll add them here. So send file descriptor and receive file descriptor. Magical. Alright. And then in process.h, you know, it's been so long since I added syscalls. It's about time we do some kernel stuff around here. So there we go, and receive file descriptor like that. Okay, those will be our implementation functions. And thinking about pledge promises, maybe these should have their own promises. Like, I guess we can invent a new promise for these. It's better than, I don't want to bundle it with some other promise, so we'll just we'll call it like receive file descriptor and send file descriptor. Yeah, that's fine, because then we can control kind of nicely who can do this. Okay, send footer and receive footer. Okay, and then we need to turn this guy right here into a socket. And oh my gosh, it's been so long since I've been in kernel mode. Let's see if we can do this. So file description for the socket FD. If no such description, return ebadf. So far so good. All right, and if this is not a socket, return not sock. Okay, and then if let's say socket description socket. All right. If socket is not, if it's not a local socket, that's not the right type of socket. What do we do for that normally? I don't know what's the best error. Maybe E not. There's some error for this. That's like, this is the wrong kind of socket, bro. But I don't remember which one I'm supposed to use. Is it E and val maybe? I mean, I guess we can use E and val. That's pretty okay. Some say E and val. That's the wrong kind of socket. All right. And then. And then we need to check that this file descriptor is also something. So here, actually, let's call this socket descriptor, socket description. All right, and then the one that we're passing descriptor. Let's call it that, because we didn't quite pass it just yet, but we will hopefully. File description for FD. All right, so if this does not work out, if there's no such thing, then we will just ebadf. But otherwise, at this point, we should be good to go. So at this point, local socket is a static cast to local socket, and wait, what's wrong with that? Kernel socket cannot be bound to that. Why not? Local socket is a public socket. Socket is const. Oops. Oopsie doopsie. Okay. Wait, why did I get a const here? The socket description, is that const? You const, bro. It's just a ref footer to a file description. Why are you picking the const variant? Okay, I guess we don't normally do this. What am I missing here? Non-const L value, yeah. Do I just not see the class, maybe? Am I being fooled by a forward declaration here? I was being fooled by a forward declaration. Silly me. Okay, so at this point we will send FD and we will send the passing descriptor. So this goes to the other side, basically. And this is something that we have to implement, and I guess we'll have that function return something. Okay. And for receive, it will work, it will start out very similarly, right? Like we have to validate that this is local socket. And I guess if it's not connected, then we can also give up. So if it's not connected, not what is that thing called? Enotcon? Do we not have that? Enotcon? Oh, I was wondering why it wasn't auto-completing. So we have that, okay. So yeah, so receive, and then received FD is we need to, so when we're receiving a file descriptor, it's not going to get the same file descriptor number in the receiving process, most likely, right? I mean, sometimes it might, but we have to make space in our file descriptor table for this. So the way we do that is new FD is alloc FD. So if new FD is less than 0, then this is a no-go. So it would be like EM file or whatever. Yeah. Too many files open, bro. But if we can allocate one, then we can fetch a descriptor from the other side. So received descriptor is local. Oh, let's cast that pupper. All right, so local socket receive FD. Like that. Okay, and then if no receive descriptor, then I guess, what do we say? Try again later. I don't know what error to give then. But we just give some error, right? Like, so E again, maybe. Or enoent, or I don't know. E again is a little bit misleading, I suppose. Enodev. I don't actually know what would be a good error message for this. Let's say enodev, because I don't know why. No such device. All right, and then if we do succeed, then we need to file the, wait, how do we store this? I forget how this works. MFDs, new FD dot set. the received descriptor. Yes. And we need some flags for it, so we'll just start out with flag 0, whatever. You can control if you want to change the flags. And finally, we will return the new file descriptor. All right. I think those are pretty decent syscalls. I don't know if I forgot something. So now we have to go and implement sendFD and receiveFD on the local socket. So let's see how we do this. I can put these up here. So sendFD file description. So I was thinking in my head here, like, should this be like a queue of file descriptors, or should we just have like a slot where you can put a file descriptor and then you wait for the other guy to receive it? But I feel like maybe a queue makes sense, because then you could imagine sort of an asynchronous service that produces a series of these things, and it might want to send 3 file descriptors to his peer, and then we don't have to block waiting for the peer to receive each file descriptor, and because then we would ping pong back and forth. It would be nicer if we can just enqueue 3 file descriptors, and the peer wakes up and dequeues them. So I think we'll do a queue. And obviously this queue should be bounded somehow, but let's not worry too much about that right now. So that'll be our API. And then I guess we'll have a vector of refputter to, or let's have it non-null refputter vector to file description. And actually we need 2 queues because they can send to each other. So there needs to be a, how does that work? A send side queue and a receive side queue, I guess. So we already have for client, so the regular data streams are buffered down here for client and for server. So FDs for client, let's call it. So this is like data for the client and data for the server. So we'll have parallel names, so like that. Okay. And then I guess, oh, wait. We need to, when we call these APIs, we need to pass in the file description through which we open them. So we need to give this thing to the sendFD API, because otherwise he doesn't know, the local socket class doesn't know if he's being called by the client or as a server, because a local socket in the kernel is actually one object, and then it has like a client buffer and a server buffer, and then both the client and server processes can read from the same thing, because the thing that determines whether you're a client or a server is the file description that you provide, that you're accessing it through. So that's why we need to just provide that here. So like that. And likewise when we receive. So here. Socket description, right. And we need to make these guys take a file description. So in this case, it's not super obvious which is what, so we'll call it socket description and passing. Description, yeah. Okay, let's do it this way. Otherwise, if we don't name things, when you have 2 of the same type in an API, then I tend to name both of them, because otherwise it's not obvious here what's going on, right? Like this signature is really ambiguous. So it's like returning a ref footer to file description, but it also takes a mutable reference to a file description. So you could imagine that this API actually receives something and like overwrites this, for example. It's not completely obvious that it doesn't work that way. So let's name it. Okay. And this thing needs to be released as a non-null. Okay. Now, finally, we can go to local socket and actually implement. So, that was the local socket send footer. Now I'm thinking, should this actually return void? That seems unnecessarily simple. We should probably return a k result so that we can indicate failure. Even if we're lazy and we don't bound the queue right now, it would still be nice if we can do it later. Send foot. Right, so result. Let's say. And maybe this thing should be a k result or yeah. Okay. I'm just starting to remember what the kernel APIs normally look like. Okay, so that's our first API, and then k result or non-null ref footer to file description local socket receive file descriptor. Okay, and let's see that we were calling these nicely. So receive descriptor or error. So if it's an error, then we can just return the error. Otherwise, wait, what's wrong with that? It's an R value reference. Okay, right. Wait, do we have like release value? Yes, we do. Okay. Thank you very much for that k result. Okay. So, to determine if we are on the server side or the client side, how does that work again? We get the role from the description. Oopsie. Wait, what am I even doing? Wait. Receive buffer for. Okay, so this is what we do. We call role with the description, and then if our role is that we accepted the socket, then we are the server. If our role is that we connected the socket, then we are the client. So we might have something actually like, actually let's make a helper. So that would be the FDQ for no ref per vector 2 file description. Yes, and then okay. So it's a little bit of a strange thing, but I think that will be helpful. Okay. Oh, wait. We need two of these. So this is like the send FDQ4, and we also need a receive FDQ4. So maybe we didn't need these to be helpers, but it'll be a bit nicer this way. So receive, if you are connected. Wait. Okay, my brain is stopped. Reboot. when I'm doing a sendFD and my role is connected, then I connected the sockets so the FD is for the server. Right, and up here it's the other way around. Yes, of course. So, sendFD Q4, socket description, append, move and passing description, return case success. Yeah, so this is where we could do stuff like have some sane limit so that you can't enqueue a Boolean of these things. Maybe we should have some sort of a sanity, just some sanity number here. If, let's say, auto queue is that, and then if queue size is greater than 16, I don't know, just some number, return like busy or whatever. Fix me, figure out how we should limit this. That's just how we should limit this properly, let's say. So it's just to have something that stops the train if it starts to go too fast. Otherwise, queue append, and we are good. And then when we want to receive, I guess we just, I was thinking, should we change it from a vector to a queue type? Maybe we should. So this is the receive FD queue for the socket description, and if the queue is empty, return what? Oh, we had some, I already had some error in mind here, like no dev, right? Need to change that at the call site. Oh wait, I guess it already took care of that. Right, of course. So return no dev, I don't know, we'll put a fix me here as well. So fix me, figure out the perfect error code for this. All right. Otherwise, so by the way, we need to lock this thing while we're doing this kind of stuff. I just realized. I don't want to have a race here, so let's lock the socket. There we go. And queue take first. Maybe a vector is fine right now. It's not the end of the world. We can replace it with a queue type later if you feel like it. I think this is pretty okay. So I wonder if this will work. It'll be interesting to find out. I guess we don't really have a test program for this, so we'll have to make something. What if we just make a little test programs? So we can call them RFD and SFD for receive file descriptor and send file descriptor. So RFD. Okay, now it's been a while since I wrote any code like this, so we'll see how this goes. I've been at such a high level lately for quite a long time, so it's nice to be back in the low level space. So I guess we'll just, oh man, how do you open a socket? Okay, socket. Socket, yes, F Unix. I forget how all of this works. Sock stream, right. Sock stream. And, oh, actually, we can just steal some stuff here. This will be faster if I just do this. So, yeah. Okay, and I guess we are writing in C today for some reason. A little bit gross, but fine. So we'll make a thingy here. Just call it something. Food socket. Okay. And then here we are connected, sending the FD to server. Oh wait, this is the receive FD program. So we should connected, receiving an FD. And then what we'll do is we will just requifd. I mean, maybe we should return E again if you try to receive a file descriptor and it gives you nothing, because it's not, this doesn't block or anything, right? So quite literally, you might have to try again if your peer just didn't send the thing yet. But anyway, so we'll rename this thing here. This has a silly name, sockfd. Okay, so our received file descriptor is this, and we'll say received fd. Oops. So if it's that, then we'll pair, return. Otherwise, say thing, and let's have a little celebration thing. All right. So that's the receiving side, and let's do the sending side. So be kind of the same program, except I guess actually the receiving side should really have started listening and stuff. Right. So we should actually why do I not remember how to do anything Unixy? So bind my socket sockfd to construct sockaddr address, and the socklen is, I guess, the size of my address, I guess. All right. Oh yeah, of course. Okay, so if that fails, then we will pair bind return 1, sure. Also, this is supposed to be the receive program. Everything is so confused here. Okay, so again, the receiving program here has to bind and then listen sockfd 5 or whatever. If that fails, pair listen. Okay, and then we have to accept. So accept. Wait, why is nothing auto-completing? Did I ruin something there now? No? Okay. So accept on sockfd, and then we need a sockaddr and socklen star, I guess, for our peer. So we'll just store that in a sockaddr un. Okay, what is the API? I'm totally forgetting everything here. Maybe we can just pass null putter. Can you pass null putter to accept here? And TCP local socket. Can you pass null putter to accept? I should know these things, but I just somehow don't remember. Local server accept. I guess we have to do something, so we'll just do this. Accept. Okay, so connected, receiving. Cool. So finally, on the sending side, this is where we connect. Connected, sending an FD. So we want to send an FD, and this will be our sent FD. So we have to open something to send to the other side. Sent successfully. Okay, so what we're gonna send is we'll open Etsy motted, the message of the day, the MOTD. So and we'll open that for art only. I guess we need for control for that. Okay, so we send that to the other side, and then of course the demonstration should be that we actually read from that and print it. So we'll do something like this, right? Read from RFD into buffer, size of buffer. If nred is 0, break. If nred is less than 0, something went horribly wrong, fail. Otherwise, just write to stdout file now with the stuff that we read. Boofer and nred. And why don't we do a little double check here? Just because. Okay, so now we have written the kernel space code in 2 test programs, and we didn't try anything yet. So I guess this will be the big moment. A sip of tea for good luck. So if we run RFD first and then SFD in another terminal, so RFD, that immediately failed because I need to probably do CMake again so that I build those things. Yeah, okay. And then we had some stupid bugs that I should have caught. Where are they? Line 31. 27. Wait, what? Oh yeah, that's what's even going on here. Why isn't the IDE telling me that something is wrong there? I am missing something here. Sock adder. Unknown escape sequence. Oh, look at that. Okay. 55 compile problems in the test program. All right, come on, RFD. Okay, it's running. And SFD. well, we connected, we sent accept succeeded, but we thought it was, what did we do wrong? Oh shit. We're supposed to check for less than 0 here. Okay, so if we get past the stupid problems, can we get some real problems, please? Receive FD not connected. Okay, interesting. Receiving connected, receiving an FD, and then not connected. Is the problem that the peer disconnected too early, maybe? We shouldn't let that fail just because of that. So I guess if there is a file descriptor in queue on the socket, it doesn't matter if the peer has disconnected. Like if we still have the socket open, we should still fetch the file descriptor, even if the peer is dead. So that was an oversight. So not con does not make sense for receiving, only for sending, because you can't send if there's nobody on the other side, but you can receive if the person on the other side sent something and has since left the building, right? That's still okay. So let's try that again. So receive and send. And we crashed. Assertion failed. Local socket 407. All right, what did we do wrong? Assert not reached. So we want to receive for this, and our role. Wait. I'm screwing something up. I'm forgetting about the accepted thing in RFD. That's a stupid problem here, by the way, but when I'm accepting, I'm actually getting a new file descriptor, the accepted file descriptor, so we need to stash that. So accepted FUD. Because the sock FD, this is my server socket. The accepted FD, that's my accepted socket. And then we need to receive on the accepted socket. We shouldn't assert just because you're trying to receive on a server socket, but that's a separate issue. No such device. Interesting. Sent successfully and then no such device. So why did we do the no such device thing? Local socket. Because the queue is empty. Okay, am I dum-dumming something here? I'm probably dum-dumming something, so we'll do like this. Send to queue name, I don't know, something like that, and then we'll just say const char queue name if queue is the same as mfuds for server. This will be very ugly, but who cares? For server, else foods for client. All right, serious programming happening right now. Okay, receive from foods for server. Oh wait, I guess this is a race. So that's what I was talking about, that we can do E again. and we can just loop, because then it will sort of be, it will, instead of having blocking behavior here, we could just say that the server and the client, they have to negotiate through protocol between each other. That like, if I send something, it's you know, it's up to you to realize that you need to receive it now, instead of defining that behavior in the kernel. It seems easier to just say like, oh, the client and the server, they will negotiate that. So because that's what we'll do in our IPC layer anyway. Like we'll, when we eventually get to the higher level code, we'll just say, I want to send a file across to the other side, and we'll deal with that somehow, somewhere. Anyway, I guess if this is, let's see, int arfd, so for if arfd is e again, then let's just try again. Otherwise, if arfd is a failure, actually if otherwise break, yeah. You can write it this way too, I guess. While I don't know if I like this way of writing it. I mean, this is just throwaway code, so it doesn't matter. Oh, okay, I'm an idiot. It's error node that I want to look at. Okay, what am I even doing with myself? Receive FT, success, not an error. Okay. So RFD is less than 0, but errno is 0? What happened here? Wait. Okay. Can this get any sloppier? All right. I should have started earlier in the day, I think. We received a file descriptor number 5. We tried to read from it, and we got bad FD number. Well, that's a start. Wait, what the actual heck? Okay, now we're hitting some bad kernel behavior. Kernel crash. I guess we must have messed something up pretty bad. Why would it get a bad FD number? So receive descriptor or error. Okay, so we don't need this gunk. So, wait, why would this fail? I don't get it. Let's see it again without all the debug output. Bad FD number. And then if we run RFD again, then we hit kernel crash. Very, very bad. Okay. So we're doing something very, very stupid in the kernel somewhere. But what? What would that be? I guess in this case we should let's see. If role for socket description is let's just bail if this is a bad situation. Role, if role is not role connected and role is not role accepted, then return. So yeah, Ian Bow. Do the same here. Huh. I wonder if I'm doing something, if I'm being too clever somewhere. It's just not obvious to me where that would be. Passing, yeah, right. So what if we just start? Hold on to it while we call. I guess we should look closer at the actual error output. I'm just assuming here that it's going to be something obvious, but it's not. So I can just do that. Okay, wait, desisting. Okay, well, that worked. Okay, let's start over. I don't know why it worked that time, but if it was because of what I changed there, let's see. So RFD and SFD, and that totally works. That's really cool. Oh wow, this thing is a little outdated. We should update the MOTD. Take a little detour here. Welcome to Serenity OS. Copyright. Serenity OS developers. Yeah, that's nice. So let's see that comes out right. So what the heck is actually happening here? So it works now that I changed those. So what we were doing before was that I was trying to be too clever apparently and releasing my pointers so we could use the move constructor, but it seems like that messed something up. But I am not at all sure why. So this works well. And oh yeah, let's have it match the license file. Doing important changes here. There we go. Yeah, base update MOTD since it was a little outdated. I'm still not quite sure what the MOTD is for. It just feels like it's the sort of thing that we just need to have, right? And I guess my idea was always that if you SSH into the system, once we have an SSH server or something like that, then we would show this banner. Because I know some people think that you could show this banner. Oh, that's a stupid problem. We could show this banner in every terminal that you log into, but I feel like that would be really annoying after a while. You just get tired of seeing it, and I don't want to get tired of seeing it. Like, it's more fun if it's something that's a little novel, you know? Anyway, so this basically works. So after a little bit of debugging and stuff, we have our feature. So that's awesome. I'm gonna try it one more time because I like looking at it. Ha! Why is it? It does look a little bit like it's slow, but I wonder if that's really the case or if it's just the window not updating or what. Okay, yeah, it's not slow. Cool. That's awesome. So let's commit this feature. Wait, is anything here? Can we separate anything out? Nope. Kernel plus libc. Add receive fd and send fd syscalls for fd passing. Let's write it this way. These new syscalls allow you to send and receive file descriptors or a local domain socket. This will enable various privilege separation techniques and other good stuff. Very, very cool. And I think that's pretty good. Now, the true good boy thing to do is to write man pages. So let's do that too, since we want to be good about these things. So that would be in man2. Let's copy some existing page because reasons. So copy the access one, receive fd. Okay, receive fd, receive a file descriptor from a local socket peer. Right. Receive an open file descriptor from local socket peer. This is a non-blocking call that will fail if there is no file descriptor waiting in the sockets queue. File descriptors are sent out of band to not affect the regular data streams. Okay. From a local socket peer connected via sock fd, yeah. I feel like we should have an error list here. Yeah. So if a file descriptor is successfully received. It is returned as a positive integer. Otherwise, -1 is returned, and error no is set to indicate the error. Errors. So then I guess we gotta go and look up what errors we came up with for this thing. So this was receive FD, right? So we had ebad. The sock FD is not an open file descriptor. Or e not sock. Sock FD is not refer to a socket. Eval sock FD does not refer to a local domain socket. Maybe that should be EAF no support. Actually. Like the address family is not supported. I think maybe that's a better error code in this case, so let's use that one. Because it's the wrong socket type, basically. Oh wait, here. Okay, otherwise we can also fail in receive FD, which would be enval if it's the wrong socket role. So enval sock FD does not refer to a connected or accepted socket. Otherwise, E again. There is no file descriptor queued for on this socket. Yeah. Okay. That's pretty decent. So let's do sendFD as well. Send. I'm sure I'm making little typos and making mistakes here, but I think it's a pretty good start, and then we can always iterate. So to a local socket here. Send an open file descriptor from it to a local socket peer connected via sockfd. This is a non-blocking call that will fail if there are too many file descriptors already queued, already waiting to be received by the peer. Yeah. Okay. I guess we should have a see also section here. So let's this thing should refer to sendFD. Man, it is so comfy writing man pages in Markdown. I just love it. And we'll do a back reference. So this guy will refer to receiveFD. Okay. And then we had a bunch of the same errors, right? So sendFD, bad, not sock, EF, no support, and we'll say enotcon. Sockfd does not refers to a socket which is not connected. socketp or fd. Yeah. And then in here we could get enval for the wrong kind. Yes, and ebusy. There are too many file descriptors already waiting to be received by the peer. Okay. Let's see if we can look at these in the help viewer. Help. Okay. System calls. Send FD. This looks really cool. Good. Man, the help system in Serenity is so beautiful. I can't get over how awesome it looks. This is exactly right. Like I feel like this is maybe the most perfect application on the system. It has everything. It's just so good. Maybe it needs like a little bit more toolbar buttons for something, I don't know. I mean, obviously any app can be made better, so, but it's just, it's such a good app. All right, so I'm just not going to overthink this. I think we will be happy here. So if I messed something up, then I'm sure that you will tell me in a comment. Or Sergey will tell me in a comment on the commits. So git commit. We'll do these in a separate commit. So bloop and bloop. Document a base. Document the rec to and send footer to. Or add man pages for. All right. Oh, I almost messed that up. Okay, so I think this is going to be it for today's video. So today was just going to be about actually implementing the system calls and getting them to work. And apparently also writing the man pages. And I think this is really cool. So this will be an interesting thing to hack on maybe next time. I don't know what we'll do next time, but to start using this to pass things between applications. But this is where we get off today. So if you made it this far, then I thank you for watching, for hanging out, and I hope that you saw something interesting. And it was really fun to work on the kernel again after kind of a long time since last time. So I hope that was interesting too. And other than that, I got nothing else to say. So thank you for hanging out, and I will see you next time. Bye.